Blair and I are grooving. Are you ready to start the science moving?
I love that you and I were dancing in the backstage, so you and I could see each other.
No
one else could see it. It was just for our little benefit.
Yes, it's all. Sometimes you just have to do something for yourself.
Yeah.
For your own enjoyment. Yeah. This is the TWIS podcast broadcast. Welcome, everyone, to the show. We are so ready to get it started. This is the part of the show where I say, hey, look at that Ewok over Blair's shoulder. And hey, he's a cutie. And when things go wrong, and I say things that I shouldn't, they should get edited out by our wonderful editor, Rachel. And when Rachel edits things out, it becomes the podcast. And the podcast is a separate stream that's edited and great for you if you don't like all of the futzing about and the errors and the other things. So right now, make sure you are subscribed where you want to be subscribed. Podcasts, live streams, Twitch, Facebook, YouTube, Apple, Spotify, I don't know, all the places where you might be getting your media these days. Make sure you are signed up to hear from TWIS. And tell your friends, hit the likes and hit the stars and shares and everything right now because we are starting the show. You ready, Blair?
I'm ready.
I'm ready too. Okay. Is everyone out there ready? I hope you're ready. I see Derek Schmidt. Let's go. Yes, let's go. Let's go. Starting the show in 3, 2. This is TWIS. This Week in Science, episode number 1063, recorded on Wednesday, June 17th, 2026. The ladies want smarts. I'm Dr. Kiki, and today we will fill your head with pregnant moms, forever chemicals, and sexy spatial cognition. But first, disclaimer. A non-injection universal COVID vaccine might be on the way. HPV vaccination keeps cervical cancer at bay, along with all sorts of other nasties. So, protect your sons and daughters today. Without routine vaccination, we run the risk of running natural experiments on ourselves. What do we think we will learn by discarding the evidence of decades past? We know once upon a time, many of us died or were damaged, disfigured by diseases that ravaged. We created vaccines to control those demons. But nuance to treatment came with costs of their own. So many lessons were learned over so many years at a price. But of course, we still can't target our targets perfectly. There are so many parameters to consider and so much science still to be done. But is starting over really what we need to remember that we already have the technology and the know-how? And This Week in Science coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
And a good science to you too, Blair, and everyone out there. Welcome to another episode of This Week in Science. We're back again to talk about all the wonderful things going on that we found worthy to share this week. Oh, what a wonderful week it has been. The good, the bad, the everything. And we're here to talk about things. I have stories from the underground. I've got a question of forever or just for now. I've also got some blood thinning news. And I've also got, what did I also bring? Oh, yeah, I've got knee pain. I'm looking for skills,
we
or
all?
at least, yeah, at least some lady birds looking for skills, some critical gamers, and possibly an immune response. what's what's in
Don't
the
we
animal?
all? Yeah. Yeah.
What's in the animal corner, Blair?
Oh my. I just have a litany of stories related to animals communicating threats. And I will leave it at that. Oh, and I also have some climate change news before then. So
That makes me feel threatened as well.
mm-hmm.
I feel like you're just coming in full of threats, Blair.
Yeah. Aren't we all?
We're threatening you here. No, the animals are, the climate is, but it's just the stories.
They're
It's
just
not us.
responding to the threat, all right?
I feel
Part of
threatened.
staying alive is recognizing threat. That's really what this is about.
It's so important.
Yeah.
Thank you for saying that.
Yeah.
If only people could see the threats that were right in front of us.
You know, like by, for example, I don't know, just at the top of my head, taking a vaccine that is proven and tested and will keep you from dying.
Yeah.
Just a
and
thought.
so yeah, and so that's what the HPV vaccine news this week in the Lancet published a study from the UK in which they're basically looking at all the kids that were vaccinated 10, 15 years ago. I think it was 2012 when the vaccines became available, and the kids that were vaccinated, they started vaccinating girls at the age of like 12 to 13 years old in like around 2012. And they're adults now in their 20s when women begin to show signs of cervical cancer, and rates of cervical cancer have been increasing around the world. They showed 100%, like basically, I mean, not 100%, nothing is that perfect. I'm not going to say that. But they showed the HPV vaccine directly is linked to a decrease in cervical cancer rates. People who are vaccinated for HPV as a child, or at any point really, they're much, much less likely to get cervical cancer years later. And this also applies, they said, to other forms of cancer that are related to HPV infection. Additionally, it has kept, this study wasn't about males themselves, but by vaccinating males, it reduces the spread of HPV to women who would then get cervical cancer. So if you vaccinate the boy children, it also keeps the girl children from getting cervical cancer and keeps the boys from getting warts and other things. So,
well, it's also
anyway, great evidence of very beneficial result of vaccines.
Yeah.
I'm just going to say, well, what are you humming?
Yeah, so I just, without giving too much personal information out, I will say that I was of a prime age to receive the vaccine when it came out.
Yes.
And I had a doctor who convinced me not to take it because it was too new. And I actually had a pretty serious cervical cancer scare shortly thereafter.
I remember.
And so I keep thinking back to that time, and I know that doctor meant well. Like that's their whole job. But I don't know where the communication breakdown was, but somewhere along the line, this doctor's medical advice was don't take the vaccine. And I had a real negative result after that suggestion. And I took the doctor's suggestion, which should be usually an easy thing to do, right? Like, well, if the doctor's saying that. So I think that, that's also like, if you are a healthcare provider, you owe it to your patients to also know what the testing was, what the failure is, what the failure case is, and is that worse than potential side effects in 10 years you're not sure because it hasn't been around that long enough? Like, what are those potential side effects? Are they as bad as the failure case of cervical cancer? If they are not,
And they were not.
then you should be suggesting the vaccine.
Yeah, but the thing is, by the time that a vaccine is approved and it said this is too new, it has been tested for probably over a decade.
Mm-hmm.
And so it's not necessarily new. It just hasn't been as widely distributed as it could be. There have been,
Yeah.
it's been around, it's been tested, it's been certified. And this had been tested in other countries on large numbers of people before the United States allowed it to be
Yeah.
prescribed.
Yeah, and I mean,
Anyway.
the internet was not what it was back then, you know.
Oh no. And
Nor
now
did
it's
I know
hard.
as much as I know now, you know.
Yeah.
So I was working off of the information that I had, but you know, I only share that just to say, like, as someone who is a staunch advocate for vaccines and someone who is like always the first in line for vaccines, like gimme. I was talked out of it.
But I think that's a great thing to talk about because we are all human and there is a fear level of the unknown, right? And so you don't know. And that is part of the disclaimer also is that sometimes there are negative reactions. Sometimes there are side effects. Sometimes things happen. And that is part of the, you know, the cost benefit balance, the equation that each individual, that our society needs to make. And I don't know, I'm not excited to see us have diseases like polio come back. I'm not excited to have diseases like measles come back. I'm not excited to see diseases that we have done such a good job of getting rid of through vaccines, where we're basically going to say, oh, look, we stopped vaccinating and look, people started getting hurt again. And then we'll just have to go through it and and this is the natural experiment that I'm talking about.
Yeah.
That it's like by removing vaccination or by only vaccinating a portion of the population and not enough people to have a broader immunity throughout the population, we are really setting ourselves up. I mean, it's going to be great for epidemiologists. I mean, they're going to fill their journals with research.
Yeah.
But you know, this is not good for public health generally. So
yes, we are basically, I feel like, living in a cautionary tale. Like, just every day I wake up and I'm like, what part of my life now is going to be a future cautionary tale? Like, this entire era of America, I feel like, is like the F around and find out era.
Oh.
and you know, the history book's going to say,
don't worry about balanced diets. Just eat a steak.
Yeah,
That's fine.
they messed around, and history taught us they found out. Like, that's basically what this chapter is.
It's how it works. So, you know, that is like, you know, to me, silver lining. If we can be a cautionary tale in the history books for future generations and future civilizations, I really hope that we can do good in the future in that way. If we can't do good for ourselves. Anyway, I just came up with that. I'm gonna think about that one a little bit, but I think we have a show to do. What do you have? Wait, you've got
already
a lot
did
of threats.
that. Yeah,
You've got a lot of threats. So, if you would like to make sure that you don't miss an episode of This Week in Science, make sure that you head on over to TWIS.org, where you can sign up for our newsletter, where you can find our show notes of every episode and listen to podcast episodes, where you can find our RSS feed directly, where you can find ways to subscribe on different podcast directories, or head over to Twitch, to Facebook, to YouTube, where we stream live weekly, 8 p.m. Pacific time-ish. Subscribe. Make sure you hit those little notification buttons and share with other people. Oh, and while you're at twist.org, if you feel like clicking that Patreon button and becoming a supporter of TWIS, that would be amazing. I would love to have your support. We would love to have your support. Is everyone ready? Are you ready?
Let's do it. Yes, give me some science.
Let's get science. Yeah. Okay. Ooh. First story up for the science docket. Let's go underground. This story.
Yeah, that sounds like a good idea.
Yeah. No. So this story, a lot of times I start the show with stories that are out in space that have to do with like space travel and like are far off. But this one is Earth-based. It's under our feet. It is organized by a group that is known as the Society for the Protection of Underground Networks, or SPUN. It's not spin, but it's spun.
Spun.
Yeah, they just published a study this week in Science, the journal Science. Their research is has been looking at global density and biomass of what are called arbuscular mycorrhizal fungal networks. What the heck is an arbuscular mycorrhizal fungal network?
Well, I know what mycorrhizal fungal networks are, but what does buscle mean?
Arbuscular. Okay, so these arbuscular mycorrhizal fungi. So AM fungi is what they call it. They are the fungi that do symbiotic relationships with the roots of plants and help to exchange nutrients for carbon. So they take carbon, they give the plants nutrients, everything's happy, it's all good. And so these fungi create massive networks underground that connect the roots of the plants and the plants that are above the ground, and they can spread all over the place. And there's been this big question of how far do these connective networks spread? How deep do they go? How dense are they in different places? How much are they responsible for in terms of biomass and in terms of work, metabolism, respiration on this planet, right?
All of it.
Exactly. And so they've launched along with this article in Science, they have launched this beautiful website, which for anyone who listens on the podcast, I want you to go play with this website because it's just gorgeous. And it's a hidden infrastructure. And we'll share the website. We can go through this, and it takes you through the story of these mycorrhizal networks, these underground networks, and how they started looking at them. And they call them basically the Earth's circulatory system, where it's exchanging these nutrients for carbon. And these networks grow and persist for thousands of years. But they're not visible because they're underground, right? And we don't know a lot about them. We know a little bit about them, but not a lot. And so the researchers have gone about imaging and taking cores from different locations on the planet. So they've got an imaging robot that takes measurements from these networks that they've grown in laboratories, so they could see and understand. And they've used quote unquote artificial intelligence to be able to get an algorithm to understand the growth, the rate, the radius, the mass of these networks as they grow in a laboratory situation. They've also done cores of soil around the planet. And so from these cores of soil, they've done actual in-place measurements of the real world density and and been able to take these cores from all over the planet to be able to figure out in some place like Nebraska or Kansas, what is the hyphal density in a grassland? What is the hyphal density in farmland? Let's go maybe to the Tibetan Plateau. You can scroll around in this. They have a map of the world where you can go to different places and and see where they have done their work. You can go to the Tibetan Plateau and be able to see an alpine steppe what the biodensity, the hyphal density is in these locations. So they've taken all of these 4,000 samples, these cores, 100,000 different samples, and put them together in this large a large probability model, right? And they created an estimate of all of the fungus, the fungal networks on our planet. And so they've got this new way that they say of seeing the world to predict the scale and distribution of this infrastructure at 1 square kilometer resolution around the planet. And the data that they've gotten from this suggests that some of the most important aspects of what we know about where these networks are is that amazingly, the Tibetan Plateau, the steppes, are super rich in hyphal density. There's a lot of natural ground there, and a lot of rich fungal diversity and density in those locations. But when you move to, say, Nebraska again, the grasslands in Nebraska that are not farmed have a much greater density than those that are farmed. And so what they are predicting is that we are going to see a potential problem with farming if it continues to go as it has been for years and years and years, and that the basically by not maintaining hyphal density within our agricultural lands, that we are going to it's going to help deteriorate the soil, which is a big problem already, but it is going to contribute to the deterioration of the soil over time. So anyway, for happy, healthy plants, we need to know about all of our hyphae. Let's get hyphae.
For happy, healthy everything.
For happy, healthy everything.
Our hyphae. Is the Sahara Desert like just a dead zone for fungus, or did they just not collect?
That's a really great question. So if we were to go back to the map, we might be able to find that. Yeah, we might be able to. Maybe they haven't actually gone there yet.
Yeah, because I just noticed this big black
It's a big black spot. Yeah.
And it's the Sahara Desert, and then like the Middle East, basically. So.
Yeah, I mean that's one of the limitations for sure, is not having those locations. So, but they do have in Africa. They've got places like in the Sahara. So they've got locations in the Sahara. So they do have desert. Burkina Faso, they've got a look there. Okay. We've got another location. This one is in French. I don't know. Yeah, so they don't have as many locations, but yeah, they have this one in what looks to be probably an Israeli or Saudi Arabia.
Yeah, it looks like Saudi Arabia.
Saudi Arabian desert location. Yeah. But yeah, not as many in the deserts, but I mean, this is the kind of thing where they've given it a start. And
this is enormous. Like, how many years is this?
So they started this study several years ago. They published some work in 2025 related to what they were doing here, and this year they've come out with this massive estimate of global biomass that is orders of magnitude larger than the biomass of humans, and it's amazing. And it's from their argument, and ostensibly a very, very informed argument, they're essential, right? If the plants can't get the nutrients they need, then we won't have food to eat. Then there won't be plants on the planet. So this is an essential aspect of the life of plants on this planet. Anyway, yeah, they're taking the underground and making it transparent, showing us what's out there. So it's a beautiful, beautiful story, a great map to play with. And if you're interested in aspects of biodiversity and the environment on the planets and how ecosystems work, this is it's a fun, wonderful resource to dig into. And from there, you wanted to talk about something. Did you have any other questions about this underground world?
No, I mean, it's just, it's a really cool like data source that I'm sure will get used for decades, if not centuries to come. I think that it's, of course, there's a mycorrhizal network covering the entire planet, for sure. That makes sense.
Yeah.
But I think that knowing more about like where it's growing and at what densities and what types and all that kind of stuff is going to be just an amazing data source. And I like it, just every time we have stories like this, I'm always like, see, this is what AI is supposed to be for.
Right. And this is where they're using AI as a tool to help us deal with all the data and to make these make the analysis happen and to be able to make these predictions. And so, this is only going to get smarter as we get more data, right? As we learn more, but it'll help us also figure out what different questions to ask, how to do it better. Yeah,
absolutely.
People supported by AI,
yeah,
not replaced by.
Right. Yes, doing important science that would take hundreds of years to dig through data and extrapolate, or have to do way more direct observation or anything like that. Like pushing research forward is what it should be used for. Finding patterns, extrapolating those patterns, checking the patterns when you collect new data. Like that's what it's supposed to be for, not making dumb images. Okay. Anyway, trying to scam grandma out of money. Hey, let's talk about climate change. Another really fun thing to talk about. Speaking of AI and data centers. So I spent many years teaching the public, particularly children, about climate change. That was like a big part of my job. And back when I started a climate change outreach program from the ground up, I relied very heavily on Yale's Climate Change in the American Mind study, which first came out in 2008. And it is, I do a lot of things with NOCI, which is the National Network for Ocean and Climate Change Interpretation, which is more of the how to talk about climate change. Yale's study is more about what people currently think and how to use that data to inform strategies for communication. So like they work together but separately. They're completely different areas of study when you're thinking about climate change communication. And so this is like the social science piece, and then the NOCI takes the social science, tries to develop communication tools, and then uses further social science to test the efficacy and iterate on those tools. So like now I'm getting way in the weeds, but basically the Yale Climate Change in the American Mind study has been on my radar for almost 20 years now.
Yeah.
And when they first came out, they kind of coined this Six Americas idea. And so that was their big claim to fame at the time, and it became called the Six Americas Studies and all this kind of stuff.
Right.
And so the idea was that people in the United States fall somewhere on this spectrum. There aren't people who are concerned and believe in climate change and people who don't care and aren't. It's a lot more complicated. And so you'd have alarmed people all the way on the left, you'd have dismissive people all the way on the right, but there's all these areas in the middle. And the idea is that you're not really going to do much by talking to people about climate change to change them or do anything new to them if they are already alarmed. You're not going to get them more engaged if they're alarmed. Similarly, if they are completely dismissive to climate change and climate action, you're really not most likely going to change their mind ever. Okay. But that only accounts for cumulatively 36% of America as of 2025 when they updated this. So Yale updates it quite often. In the middle here, you have concerned, cautious, disengaged, and doubtful. And all of those groups, you have an opportunity to move them down towards the alarmed side of the spectrum. So you might move them from doubtful to disengaged. You're not going to move them from doubtful to alarmed, right? And so the idea is that this kind of can almost provide like a reality check as a communicator and as someone trying to explain or persuade people about the urgency of climate change, so that you're not expecting to shoot the moon, right? You're just going to move them kind of along that spectrum so that eventually they will buy into some climate action. And I know that like since 2008, things have become much more dire and much more urgent. And also now we're moving backwards in action, which is very frustrating. But ultimately, the largest possible needle mover, at least in America, is to persuade the representatives that something needs to happen on a legislative level, right? Like you or I can install 1 million solar panels on us and all of our friends' homes and buy a Prius and like do all these other things. But unless there is legislative change, the needle's not going to move too heavily. And so the only way to do that is to mobilize people in general. And like the cool thing about that is that like you don't have to be rich to support politicians that will support climate appropriate legislation, right? So like in some ways it's more accessible to just, you know, persuade the public opinion to make these changes. So I'm sorry, I'm like laying a lot of groundwork, but ultimately the reason I wanted to talk about it today was that they did release a new version of the Climate Change in the American Mind study in last week, actually. And, you know, most of it is not that surprising, but there are a few things that I wanted to call out that was really interesting. And that is global warming as a voting issue. So they found that 58% of registered voters would prefer to vote for a candidate for public office who supports action on global warming. 14% would prefer to vote for a candidate who opposes action. So I wanted to talk about like the Six Americas thing first to explain when you hear 58%, first of all, that's pretty good. Like modern presidents don't have approval ratings of 58%. Like it's a very high percentage. But even if you're like 58 isn't enough to do anything, only 14 wants to oppose action. Only 14. So actually, you're looking at 86% of people who would not say no to candidates who support action on global warming. Okay.
Yep.
42% say they would like to hear from political candidates about efforts to reduce global warming often. 23% would like to hear about it less often. 31% they would only vote for a congressional candidate who supports increasing the use of renewable energy. 7% will only vote if they decrease renewable energy. 7%. The rest don't really care.
That's not a lot.
Right.
It's not a lot.
25% say they will only vote for a candidate who supports decreasing the use of fossil fuels. 14 increase fossil fuels. Okay. So
14% increase.
Right. Increase the
Not
use
a
of
lot.
fossil fuels. No.
Not a lot.
No. So when you hear someone say like there's not a public appetite for something or people aren't interested in that or people don't want to hear about that, think about this.
Who?
Okay.
Which people? Who?
The support for climate policies. Here we go. 88% of people surveyed support federal funding to help farmers improve practices to protect and restore soil so that it absorbs and stores more carbon. 88% of people. That's an insane number. 78% of people support funding more research into renewable energy sources. 78%. 77% support regulating carbon dioxide as a pollutant. 65% support transitioning the U.S. economy from fossil fuels to 100% clean energy by 2050. 65% of people, 100% clean energy by 2050. That's pretty soon. And then, oh yeah, here we go. 91% of registered voters think funding for the Federal Emergency Management Agency, FEMA, should be increased or kept at the same level as now. 91% of people. And that makes sense because everyone wants FEMA to come to their aid when they are in trouble.
No matter why. Like if there is a fire, a hurricane, whatever, you need the emergency response to come.
Yes, 77% of registered voters oppose ordering all federal agencies such as NASA, NOAA, and the EPA to stop doing research on global warming. So 77 want them to keep doing it. 77% also oppose ordering federal agencies to stop providing information about global warming, which has happened, by the way.
And we can talk about that. Yeah.
Yeah, and so the other thing that I wanted to like scoot down here is that, okay, so gas prices and electric vehicles. 78% of registered voters say they're worried about the current price of gasoline. Duh. 33% say they're likely to consider an electric vehicle next time they buy or lease a truck. A third of people. Oh, data centers. Speaking of AI, 58% of registered voters oppose building data centers in their local area. 60% think that if a data center opens in their local area, their electricity bills will increase. And 74% of people support a proposal requiring data centers to offset their electricity by installing rooftop solar and weatherizing local homes. And then, like, you know, there's a lot of these other things, but here's what I really wanted to get to. Efficacy. 46% of registered voters are at least moderately confident that people like them working together can affect what the local government does about global warming. 44% are confident they can affect what their state does. 37% are confident they can affect what their federal government does. And 36% are confident they can affect what corporations do. Which makes sense.
it makes sense, but all told, those numbers suggest to me that there's disenfranchisement.
Yes, this is why I wanted to talk about
this. The numbers are
all
all lower.
Everything I just said, all of the numbers I just rattled off, says there is public appetite and that the public wants change. But at the same time, they feel, less than half of people feel like they can impact government at any level. That's
the first thing that jumped out to me. I was like, people don't feel like they have a say in government anymore.
Absolutely.
And that is disenfranchised.
Yes. Yeah. And some of that, a lot of that is intentional, right? Because corporations want to keep their money and politicians want to keep their power. But I'm saying this because I'm like shouting this from the rooftops, because for everyone who feels disenfranchised, like they can't make a difference, I need you all, I'm not talking to Kiki, you, everyone listening, everyone you know, to remember these larger numbers. You are not alone, which brings me to this last piece. Information about global warming. Registered voters trust the following sources as information about global warming. Climate scientists, 71%. Happy to see that's still very high. It's actually, I think, higher than it was in previous studies, so that's pretty cool. Family and friends is number 2, 69%. Then comes their primary care doctor at 65%. Television weather reporters, this has been true for 20 years. I think this is hilarious. People really trust their weather reporter on TV. They really do, because they get to know them. They see them every day.
It's true. That's why meteorologists play such a huge part in understanding weather versus climate change.
Yes. And so that's TV weather reporters, 63%. Local news organizations, 54%. National news, 46%. AI chatbots, 24%. Thank God. Thank you, everybody. And then social media posts, 18%. Okay, so I bring this up. This is my last shout about this, and then we can move on because I could talk about this all day. But family and friends is number 2. You, again, everyone listening, you are the next to highest, most trusted, next to climate scientists, only 2 percentage points different. You are trusted, which means we have to weaponize this information that I just told you. Okay. So everyone believes it's happening. Nobody's talking about this. Yeah. Okay. And everyone feels disaffected, like they can't do anything about it. So it is now your turn. It is your time to bring this up. It is your time to talk to people. It is your time to research which candidates are climate forward and tell your friends that. It is your time to say, hey, who are you voting for? Do you know who's supporting renewable energy? Like, this is the time. Because also just telling people this, I think, is really important. Hey, did you know like 80 to 90% of people want to support renewable energy and want their politicians to do something about climate change? Did you know that? That is going to break down these constructed barriers for us to be able to make change.
And there are advancements happening globally. We have had the largest amount of solar and wind energy production ever this last year globally. The United States is also a leader in this, even though we are seeing a pullback in the funding to subsidize these things. Additionally, battery technology has hit a magic point. We've been waiting for batteries to be what we need them to be to store the energy. They are there. Batteries, battery technology, battery storage is going to grow like wildfire, and it's going to allow for more rooftop and for apartment based, like balcony based solar energy production. So people will, and what we need is the development of those the controllers, the regulators, so that the people doing the apartment solar, they don't just have to feed it into a battery that then feeds their appliances in their apartment, but can actually go into the wall in the grid in their apartment and feed into the apartment as a whole. So there are some technologies that need to be developed for regulation to make it all happen, but we are there. Like, we are at a point where we need to talk about this with our friends and our neighbors. And it's going to be affordable, and it's going to happen. We got to make it happen ourselves, though. We're going to make it happen. I'm excited about battery technology right now. Like, whoa.
Yeah, that's going to be a big breakthrough.
The battery technology has been one of the hurdles holding so many things back. And by the improvements that are happening, there are a couple of companies right now that have just taken things to another level. And it has, the battery issue is the thing that has the potential to push us forward, regardless of what is happening in our current administration of the United States. The technology is there. We can do things now. Sometimes we just have to wait until we can get there. And we're there.
Yeah. Do it.
But we need to talk about it. You need to talk about it with your friends.
Yes.
I'm going to talk about it with my friends.
Unfortunately, have to step away. I just got called away. I will be right back.
Well, I have some more stories.
Okay. Share with everybody and I'll be right back.
Okay. I'll share. I got things to share. Go have fun, Blair. Blair has been has family needs. And so the show will go on. I'm so glad you are all here right now. I'm just going to take this moment to say thank you for being here. If you love TWIS, make sure you head over to twis.org, click on that Patreon link, and become a supporter, a year-round, month-to-month supporter of TWIS. Help keep us going month after month in case our equipment breaks, and so that we can pay for these bills. The bills. Oh my gosh. So maybe I can get a solar rig. I don't know, to get off the grid. Oh my gosh. What do we all want to do? We want to live in a farm. But Science Island, we can get there one day, but we all need to work together. If you want to stick with us, of course, twist.org, click on that Patreon link. I can't wait to say your name at the end of the show. Your support is so appreciated. Few more stories before hopefully Blair comes back. I hope she's not gone for long. What are we gonna do without her? Well, we're gonna talk first about forever chemicals. I was thinking this story would come in nicely after Blair's discussion of our feelings, our perceptions of things related to climate and also the economy related to that. One of the things that has allowed us technologically to kind of live the lives that we are living right now is plastic. And a lot of those plastics, a lot of the coatings of our goods, we are covered in what are called PFASs or perfluoro. You know what? sometimes I stumble over the PFAS, and I do know what it is. Perfluoroalkylated substances. Yes, polyfluoroalkylated substances. Anyway, the PFASs are forever chemicals. They have fluorine atoms within them that are very stubborn and really dangerous, not so great in the environment. They stick around, they're bad for your health. We find all sorts of things um, that that they do that they can impact like reproductive systems negatively. They're awful. Can we get rid of them? Can we turn forever chemicals into just for now chemicals? And that is the question. So researchers have figured out, okay, well, we can use expensive enzymes. We can use like lots of processes all together, power, energy, costs a lot. It just takes a lot in terms of energy and chemicals and everything coming together to be able to break down the PFAS into smaller components. And what a lot of groups have just decided to do now is not even break the PFAS down, but just try and separate it from the good stuff so that it's a filtering process more so than a de decontamination process, right? So the contaminant is still there. In this, the researchers who just published this work from Aarhus University, their work was published through the Association of or American Chemical Society Journal of Environmental Science, and their look at the mechanistic aspects of the breakdown of PFAS, they determined that high intensity mid-range, like 300 nanometer, 200 to 300 nanometer. This is like ultraviolet light range or like mid ultraviolet light range. That light intensity at a high at a high intensity. I guess it's a amplitude at a high intensity. They are saying that they can break it down with hydrogen radicals, so basically free radicals of hydrogen and light, no other chemicals can get the fluorine from to leave these terrible forever chemicals and actually be able to get them out and isolate them and get them away. And within a period in their experiment of 5 hours, they were able to show that they could break down PFAS that they had put into their machinery to try and figure out the driving of this process. There's a lot of questions still to come. It's not like this is going to help right now to be able to clean up all of the PFAS on our planet. But in terms of our manufacturing processes or making sure that we are not putting contaminated effluent out into the world, that there can be a cleaning process before it leaves our manufacturing locations and industry, that they're suggesting that this is a potentially lower cost and higher yield, so a better impact to get the PFAS, not just from being pulled apart. So, like the nasty PFAS is just separated from the stuff that's okay, but actually taking the harmful fluorine atoms and making them into compounds that are less dangerous, that can be isolated and used and continued in other processes. So, it's I think this chemical work, this chemistry work is very important, and I'm very excited about what they're doing here. This decarboxylation and hydrogen fluorine fluoride exchange. It's this is the kind of stuff that is going to help us really clean up our environment. Fingers crossed that this bears fruit in the future. All right, so moving on from getting rid of fluorine from PFAS, we've got blood thinning. And again, I wish Blair were here for this one because she would love to talk about it. I want to talk about where heparin comes from to start. We all know blood thinner, if you've ever needed a blood thinner because of a medical condition, heparin is the compound that is used. Heparin as a compound, we've had difficulty making it experimentally. We've had difficulty making it in laboratories or at industrial scale. Where do we get it? Horseshoe crabs. We get blood thinner from horseshoe crabs, and it costs so many animal lives year after year. It's terrible for their populations and terrible for the environment that we are doing this. Yet, we need this compound because it is one of those essential compounds that allows us to save lives. So, these researchers publishing in Trends in Biotechnology this month or this week have published just today wholly enzymatic, wholly, what? No, wholly as in whole, wholly enzymatic programmable sulfation in a non animal heparin synthesis. And so, what they have done is really, truly been able to develop a synthesis paradigm for heparin that does not involve any animals. They have been able to isolate the compounds, the processes that are necessary in order to be able to truly develop something that is guided by nature. So, model animal guided sequence to be able to create a useful compound. And I think this kind of work is the stuff that is so exciting because it takes what we have found in nature and the important aspects of what is existing in nature and what helps us, what doesn't help us, and um, and takes us someplace new, allows us to separate from that reliance on animal populations, on live populations, so that we can actually develop things using technology in parallel that doesn't impact the environment as much, which I think is incredibly important. So, anyway, they have gone through processes of looking at mutations and mutagenesis and created enzymes for what they call engineered domain chimeras to be able to create these enzymatic molecules that can make sure this process can take place. And so they actually have molecules that can allow for the adding of sulfates, so the sulfation that is involved in creating the heparin molecule, which we have not been able to create ourselves to date. And so this is awesome. Hopefully, we can get this into the works sooner rather than later and get away from bleeding the animals for our own blood thinning purposes. Yeah, I think it is. I think it's wonderful news. Yes, Derek, I think it is. Moving forward there, I wonder what Blair's doing right now. I always wonder. I think it's fascinating. I used to have to run away to do the mom things quite often. But right now, thank goodness, I don't have to as much. But I feel for Blair. Okay, so the next story that I wanted to talk about um, came out last week, the day that we were doing the show, and so I didn't talk about it on the show because I hadn't seen it yet. So I brought it this week, and I think it is one of the coolest stories. It's so neat. Um, Researchers just published in Nature last week, in open access in Nature, their work that found a 5.3 million year old whale necropolis. That's what people are calling it, but it's whale falls. So ancient dead whale skeletons at the bottom of a ravine, a really, really long ravine, near in the southeast Atlantic Ocean, or near the Indian Ocean, off of Australia. There's this it's yeah, off the Indian Ocean, off of the coast of Australia. It is an amazing discovery. Researchers from China, Italy, New Zealand, they published it last week. And these bones date back 5.3 million years. 5.3 billion years. It's huge. This is a major discovery in terms of whale carcasses. Not that looking for whale carcasses is something everybody does, but when we do find whale carcasses nowadays, it is exciting because, as we have talked about on the show many times, these what we call whale falls, when a whale dies in the ocean and falls to the bottom of the sea, onto the seafloor, it then becomes a habitat. It is a decomposing body, but it becomes food for all sorts of different species. The bones, we've discovered bone worms, osedax, that we've discovered many new species of those, that some that live specifically only on whale bones. There are so many fascinating aspects of the cycle of the carbon cycle and nutrient cycle of the ocean that are very important in influencing what we have learned, I mean, specifically from these whale falls about the ocean ecology. So anyway, the this paper, as I said, it make sure that we're looking at this map, which I think is so wonderful. Um, this 5.3 million year old sequence. They call it a necropolis because it's not just one whale fall. It's carcass after carcass after carcass after carcass. It's like almost 500 dead whales in this single area, this singular area, this strip of a ravine that seems to be off of this southeastern Indian Ocean area of islands that kind of points downward toward Australia. And the spacing of it is such an interesting location. And what it seems to be is that maybe these whales have fallen, and then the bones just stayed where they were, very, very deep down in this ravine. And that is another part of this, is that these bones are older than any other whale bones than we've ever seen. It's deeper than we've ever found whale falls, and older. And so it's a very exciting discovery, um, especially so many whales. And so in the map, they show these orange dots where the whales were discovered, some with many individuals and some with fewer individuals. And there are orange circles to identify that. And there are also white circles to identify locations where they dove and they didn't find anything at all. So they have some areas within this under ocean ravine that have, in certain spots, over 50 fossils in one location. It's just it's incredible to me that whales would be gathering in a place and so many would fall in the same place, right? That this is over and over and over again. And so it shows that there are maybe specialized communities that were in certain areas over time, that these whales have lived in these areas for long periods of time. But even beyond that, it allows the researchers to they showed that the carcasses themselves of these old fossils, host very specialized communities. And so there are brittle stars, and again, more bone boring worms, the osedax. There's bivalves that live off of chemosynthesis down in the dark of this ravine. Um, and they've also seen a fossil record here that throughout the area, it shows existing and also extinct deep diving beaked whales. And this is an area where where these whales have been for 5.3 million years. I mean, it just, to me, is it's a fascinating discovery, and I just want to see more. I want to learn more. I want to know more about what they're doing down there, what they're discovering about whales and the life that lives on their carcasses, on the extinct whales. I want to know why they keep finding them in certain locations and not in others. Why is that happening? I think there's so many questions worth asking here that we don't have the answers to yet. Yes, exactly, Fada. The whales have fallen and can't get up. That's exactly what's going on. Yeah, I think yeah, I really do feel like this is a very special discovery, and we I love what we're finding in our ability to be able to get under the ocean more, to be able to do the dives like these, to be able to go so deeply beneath the surface of the sea, to be able to make these discoveries now. And like going back to Andrew Thaler's discussion about the deep sea when he was on the show a few weeks ago, the United States, we don't have a fleet anymore. We've gotten rid of all of our deep sea ocean fleet. We have like one ship, I think he said 2 ships, something like that. And so everything we do under the ocean, these kinds of discoveries, they're going to come from other countries, and it's going to be other countries making these discoveries from here on out. But they're beautiful, incredible discoveries. So they found fossil crania from this of these beaked diving whales, the Ziphioidae from the Diamantina zone, which I think is fantastic. But they've got these lots of beautiful cranial bones, lots of examples of different organisms, and this one specifically from 5.3 million years. Thanks for our dating technology to be able to figure out where things are. They use strontium isotope dating for these whale fossils to be able to figure out what species were there and when, and they were able to, like I said, take them back millions of years, so long ago, before people. So long ago. I think it's amazing. I honestly think this discovery is amazing, and I do want to hear more stories about this. I think it's incredible. And just in time, Blair, you're back.
I made it.
You made it. I was talking
Hopefully.
about dead whales.
Oh man, I'm gonna have to listen back. I love stuff about dead. I don't love dead whales. I love stuff about dead whales.
Yeah. So this one is a story. Researchers discovered a giant whale falls, like lots of dead whale skeletons underneath the Southeast Indian Ocean, like 500 skeletons along this underwater trench that date back to 500 million years ago. Or not 500, 5.3 million years ago.
Awesome.
Mm-hmm.
That's so cool.
Yeah.
I was just having a whole conversation about whale fall earlier this week, so that's awesome.
Yeah. And so it's a huge bonanza for the deep sea whale scientists who want to find these things. Yes. Hello, Radius. Welcome. Hello, everybody. I'm glad that you are here. Everyone who is here, thank you for being here. Thank you for joining us in the chat. Thank you for being a part of the show. If you enjoy TWIS goodies, head over to twis.org and click on that Zazzle link. And Blair's back right now, just in time for Blair's Animal Corner.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
Watch out
For...
Oh, you heat, snakes, various predators. Actually, I have 3 stories that are all kind of weirdly similar but different. So just a quick overview. I have zebra finches warning their unborn chicks about the heat. I have mother mice warning their unborn fetus children about snakes. And then I have rays warning their neighbors about predators. So let's get into it.
You got a warning for us?
Yeah. Zebra finches, they are able to, via warning call, change the biology of their babies to be more appropriate to the heat. Zebra finches, yeah. So that's really what this is about. So zebra finches produce a distinctive high-pitched warning call known as a heat call when panting during a heat wave. So I just picture kind of like a, which I think we actually have a recording. So hopefully, Kiki, you could play that.
I will look for that. But have you ever seen a hot bird outside?
Yes, I certainly have.
They just have their beak open. Yeah.
Yeah. The calls around developing chicks better prepare the chicks to cope with heat after hatching. But the how is exactly what the question is. How does a warning call impact the biology of the brains of a chick fetus? So the expectation was that the heat warning calls will somehow alter genes involved in the blood-brain barrier in a region of the chick's brain, in the hypothalamus specifically, which controls how the body responds to overheating. The idea is that would prepare the tiny developing birds for hot conditions when they hatch. So they're just aware they're hatching into a hotter environment. And so what researchers did is, this is in Deakin University in Australia, they played recordings of heat calls to developing zebra finch embryos, as though the parents were chattering to them during the last few days before the chick was able to hatch. And then just before the chicks hatched, they collected samples of the chick's brains. Sorry, everyone. Then they painstakingly identified which genes were switched on or off, triggered by the heat calls. But what they found was not what they expected. They expected to find something going on in the hypothalamus. None of the hormone genes in the hypothalamus had been changed. So at first they were disappointed.
What?
They were like, this is not what we expected. Yeah. But instead, what they actually did find was that genes involved in the cell structure and muscle contraction, including tropomyosin 1, which is an essential protein involved in muscle contraction, were activated after the chicks were played the heat warming calls. So it was a much more, I guess, direct route. The impact was specifically on muscle contraction and cell structure. They kind of bypassed the hypothalamus completely. They looked more closely at the cells that make up the hypothalamus and realized that the warning songs had altered the activation genes in the muscles lining the blood vessels of the hypothalamus. So they impacted the blood-brain barrier by impacting the cell composition of the muscles around the blood vessels.
Wow.
This would prevent the blood vessels from maturing before hatching, which keeps them flexible, which would allow them to be more adaptable to heat waves, so they can increase or decrease blood flow accordingly. And yes, before anyone asks, they controlled for temperature. So it was the call, it was not the temperature of the eggs. All of the embryos were at a comfortable 37.5 degrees Celsius. That's 99.5 degrees Fahrenheit, which, if you're under a bird butt is pretty normal. But so it was consistent whether they got the call or not. It was the same temperature. The call is what changed the cell structure. But to ask your question again, Kiki, how?
Why?
Why? How?
Sure.
Yeah.
How did it
Mhm.
do it? Yeah.
I don't know. They don't know. They figured out what. The how is still confusing.
Okay. Well, here's a call. You hear it?
No.
You can't hear it?
No.
Okay, hold on 1 second.
I was like, does she think she's playing something?
I do. Hold on. Try again.
It's very quiet, but yes.
That's as loud as I can get it.
Kind of sounds like a.
But high speaking.
Yeah.
It's like somebody's. It's very high pitched.
Mm-hmm.
But yeah.
And
Frantic,
of course,
even.
yes, it does sound very frantic.
I wish I could make it louder. I'm sorry, I'm not able to.
I mean,
do
it's
that.
possible that this is just like cortisone, like it's a stressful sound. Cortisone increases. This is one of the things that I don't know. More study is needed, but
more study.
yeah, I mean, it's one of those classics. But of course, this is related to climate change, right?
But the hypothalamus for stress should be involved.
Yeah.
In the signaling, and they didn't see the hypothalamus being involved. So how is still the question.
Yeah, for sure, it's still the question.
Why?
Yeah.
Why? How?
And of course, part of the issue here is that, yes, climate change. And so warmer temperatures, the calls are related. But if the calls are how they adjust their physiology to a warmer environment, if the environment is changing too rapidly, you could call all day. That's not going to change anything. Plus, if every bird is panting, is everybody going to change their physiology? So it's, it's kind of like this is a strategy that works in a variable environment. When the entire environment shifts, it may not change. What if all the finches acclimate and then they're not making these stress calls?
But at a certain point, the physiology, it doesn't matter.
Right.
That's just their panting stress call all the time. It doesn't matter.
Yeah.
The young in the egg have adapted, and they adapt to the maximum that they can, right? They are not, if there's no more that they can adapt, because there's only so much variability within the system to begin with.
No, totally. And ultimately, the species have, hundreds of thousands, millions of years of evolution that have been based on a gradual and variable space. So when you just kind of put your thumb on the scale, things aren't going to work the way that they used to work. So it might be a little too late. But ultimately, it's cool to just, like, the mechanics of it. I think that's what really I found interesting, that a verbal cue from a parent to a fetus still in an egg can impact their body later in life.
And that to me is how, because I have no problem understanding how a developing individual, a developing bird in the egg, can hear the sounds of the parents talking to each other, that there can be, we talk about this with our own offspring, right? Play your baby Mozart while in the womb. I mean, I don't think that is as prescribed as a thing anymore.
Talking to it is what's important, I think. Yeah.
Yeah. That the talking, that there is a certain level of awareness of the external environment, even though the fetus doesn't really realize that is an external environment, right? That the perception and the cognition of an awareness is not there yet. But there is
response to stimuli, for sure.
Response to stimuli. And so this is a very specific stimuli that is auditorially based, that leads to a stress response that changes cellular structure. This is amazing.
Yeah.
This blows my mind, Blair.
Well, get ready for your mind to be blown again, because
I know Arnlor is asking, how do we know that that's normal? Well, it's not normal. That this heat stress response is it shouldn't get so hot that the birds have to do that. So it's an adaptation, but a normal adaptation within normal variability bounds.
That's right. Yeah, so my next study is about mice, a Pacific pocket mouse, and specifically the fact that they are endangered and they are being raised in captivity for release in the wild. And when you do that, obviously there's a lot of benefits because you can reduce stressors from the natural world if there's competition for resources, if there's predators, if there's invasive species, like anything that might hinder them growing up to be adults, you might raise them in captivity, get them nice and strong, and then release them into the wild. But there's some things to consider when you're doing that. If you think about like raising condors or bald eagles, they're always feeding them with these puppet hands, right? To try to like not get them too acclimated to humans. But also,
you don't like humans. Humans will not be nice to you.
Right. You also have to make sure that if they are a prey animal, like a mouse, that you are sufficiently scared of predators. So the question is, can you train a predator response, like a fear response to predators, into captive animals prior to release? And is there a way to do it at scale? Because to train every individual mouse before you release it into the wild is not practical. So
basically horror movies.
Yes. Yeah. It's like snake horror specifically, right?
Horror movies for little rodents, yeah.
Right. So anti-predator training is what they call this, but now the study is all about doing anti-predator training on pregnant mothers. They have shown for the first time, this is from, San Diego Zoo Wildlife Alliance in Escondido, California. They've shown for the first time in an endangered mammal that predator training of pregnant mothers can influence how the offspring respond to predators later in life.
How?
Well, so we have talked on this show about studies where impacts to mothers or sometimes impacts to grandmothers can show up in children or grandchildren.
So for the grandmother to grandchildren impact, that's usually epigenetics, right? It is something that's passed on epigenetically. Is that how? And from the mother.
Let's read through it and learn together, shall we?
Yes,
okay, so
let's go.
What they did is they took the Pacific pocket mouse, which I'm going to try this. Ready? Parognathus longimembris pacificus.
Really well done. There we go.
Thank you so much. They had a randomized controlled experiment. They had 22 pregnant females in the second half of gestation. They filmed them for 20 minutes, and while they did that, half of the females were assigned to a predator-exposed treatment in which they were placed in a testing arena with food. After acclimatization, a live king snake, was introduced behind a wire mesh. Everyone, okay, great. Pocket mice were sprayed with water when they approached the snake. This is the anti-predator training. They didn't automatically know to avoid the snake. They didn't want to endanger either individual, right? So if they let them in common space, the mouse or the snake could get injured. This is one of the reasons why you don't feed out live prey in accredited zoos, for example, is because sometimes the snake will strike and accidentally hit themselves, or they'll ram their head into a wall, or
you don't want to hurt the snake.
You don't want to hurt the snake. No. It's also just generally not. It's cruel to the rodent, right? But so they wouldn't let them in common space. They also would not just let the snake lunge at the mouse for the same reason. It could hurt either of them. And so instead, the anti-predator training was a spritz with water, which is just snake is bad.
Oh.
Yeah.
Done.
Yes. So the mice received scores for behavior, location, and orientation relative to the snake. The remaining pregnant females were control. They put a rope in the exhibit with them behind the wire mesh. They were not sprayed. Once pups had been born, 87 of them were born in total, and they reached 30 days of age, they tested their behavior towards a snake following the same protocol. 44 offspring were then released into suitable habitat in coastal Southern California, while their post-release survival was assessed. So they first wanted to see what their predator response was, and then they wanted to see if this actually impacted survival, which I love that piece of this design, of this study, because they took it a step further. They didn't just say, like, we extrapolate that their survivability would be. No, they actually tested that part, which I think is really...
How did they act, and how did they do?
Did they survive? Yeah. And so they showed that in the snake's presence, this is important and very interesting, daughters of predator-trained mothers displayed more vigilance, scanning, freezing, and rearing up to monitor their surroundings. There was no difference between sons of predator-trained mothers and sons of control mothers.
Huh.
Yeah.
So it's being passed along on the X chromosome.
I guess.
Somehow.
They concluded that giving anti-snake training to pregnant females makes their daughters, but apparently not sons, more cautious around snakes.
Because you can't make sons more cautious around anybody.
I mean, that is true. So the next question is, were the daughters better at surviving in the wild? They found no boost on survival after release.
Oh, wow. Okay. So even though they were behaving better, had more of the survival behaviors.
Yeah. Now, they do caution that this is a pretty small sample size. They didn't follow them for a long amount of time.
I mean, you can't follow them after they're dead.
True.
Oh, sorry.
So I think that, there's a lot more to be studied here.
Yeah.
But the thing that they can tell is there is some sort of passing of information happening here. One possibility is prenatal programming, they say, where stress hormones, that's what we were just talking about, associated with predator training during pregnancy influenced offspring development before birth. Another is that mothers behaved differently after the pups were born. Then that shaped the baby's behavior. It could also be there were some sort of odor cues from the anti-predator training in the mother, like stress hormone odor cues on the mother. So again, sorry, Kiki, we don't have the how.
No. Yeah.
So we need those still.
But okay, so I'm looking at the survivability data here, and I think what's interesting is that the males generally are better at surviving when they were first released, control males and the treatment males. They survived better than the females at the beginning.
Interesting.
But that changed over time.
Yeah, the treatment males, oof.
Yeah, but the treatment females, while others, and in this, and it's probably, this is variability of individuals and situations, but they're looking at the treatment females actually seem to maintain their survivability at a fairly constant level compared to everybody else.
Yeah.
At a very similar level, actually, to where the control males were for most of the experiment. Yeah. It's a really interesting result at how it comes out. But yeah.
I mean, the big takeaway here is that treatment of the mother did impact the behavior of the daughters. Yeah.
But this is all still in the laboratory before they released them and actually had real world experience.
Yeah, I think that this would be really cool to do you could do some sort of, oh gosh, it would be tough to do, but if you could somehow do kind of like a baby swap. Specifically for like a habitat where all of the large predators have been eradicated.
Where there's none.
Yeah. And an area where there still are natural predators. And then you could kind of see, like, does it matter?
So like New Zealand versus
oh, because of the cats?
No, the cats, that cat, if you could keep away from the cats, but
yeah. Well, anyway, yeah, so that's my second threat story. My last one
is actually
about bat rays. So bat rays, they're elasmobranchs. They're in the group of rays, sharks, and skates. This is what I think is really funny about this study is that they're really excited about observing something in rays that has not been observed in cartilaginous fish. It has only been observed in bony fish, which I'm like, my buddies, they have a common ancestor. So maybe there's a common anyway. Okay, so that's my like asterisk before we even start. But this story is all about how frightened bat rays appear to produce some sort of chemical cue that warn others around them of danger. And so even if another bat ray cannot visually see the ray who feels threatened, if you pump the water from the threatened ray into the non-threatened ray, they will act threatened. They will act like there's a predator.
Yeah.
And so the really exciting thing about this is that usually you think about elasmobranchs like sharks and you assume that they're the top of the food chain, but they aren't. There's whales.
Are they scavengers? Are elasmobranchs like are rays? I don't ever think of them as like they can do damage.
Oh yeah,
but...
so the larger ones will definitely eat. They'll try to eat fish. They'll eat like flounders, especially anybody that's out on the bottom.
Flounders because they swim flat like like the rays do.
But also,
I'm just imagining the mouth of a ray like on the bottom of this very, you know, alien ship like body.
Well, and they have the little grinding teeth, so they're also I would say they're largely scavengers, but they will try to hunt also.
Yeah, they're gonna get what they can.
Yeah. But they're closely related to sharks. Sharks, hunters, you don't think about them as feeling threatened very often, but hey, there's bigger sharks. There's also predatory whales. So there's lots of opportunities for sharks to be eaten as well. There's also lots of tiny sharks. I feel like everyone forgets that sharks are just fish, and there are tiny sharks that are also on the menu.
I forget about the tiny sharks too.
Yeah, like little dogfish sharks. Like everybody's eating them. But in this study, they had these two different tanks. They scared a ray
with water.
Yes, and well, they scared the first ray. How did they do it? Now I'm losing it. So for the experiment, they had 3 tanks. Each had an individual bat ray, one signaler tank that followed the 2 receiver tanks. These tanks were visually and acoustically isolated, so they couldn't hear each other either. After the rays had the opportunity to settle, they simulated a predator in the signaler tank by chasing but not harming the ray in the tank. So they just kind of like corralled him around, made him feel stressed.
Yeah.
The overhead cameras monitored the behavior in the receiver tanks before and after, and within seconds of the water from the signaler tank flowing into the receiver tanks, the receiver rays exhibited obvious behavioral changes, including swimming at high velocity, evasion, and flight response. So
how? Why? Yeah, so how does the water tell them?
Yeah, I mean, honestly, stress hormones, right? That's just it. That's just the answer.
Yeah,
it's probably just stress hormones. But also, like, there's all sorts of chemical signals happening in the water. Always, but especially in the water, right? Yeah.
Elasmobranchs, the sharks, we know they have their EMF, right? They have their electromagnetic sense, and can they give eels can give off electric shocks.
There's, what are they called? They're called, I swear I'm gonna get it, the ampullae of Lorenzini.
Yes.
I gotta look it up.
You got it. You did it. That's what it is.
Those few years working in an aquarium still got
really
it.
Paid off.
Yeah. So that they can totally tell chemical cues. I think that if they're acoustically isolated, the electrical cues in theory shouldn't be carried.
Should be. Yeah, they should be isolated also.
So it really should just be kind of a hormonal cue. That's awesome. Which again, like,
awesome,
water is not usually super, if you live in the tropics, you can see really well, but most water is murky. Yeah. So you would benefit, everyone would benefit from a stress response being transmitted. Like all fish would benefit, which is the other part of this study I think is so funny, is like, this is the first time in a shark or a ray we've seen this, but we've seen it in bony fish a bunch. Like, well, duh. They're all just fish, guys. They're all fish.
So this is like similar to studies that we've had talking about like plants and their response to chemical cues, where a deer eats a leaf and a plant emits a chemical signal into the air and also throughout its own structure, right? So we know that plants in the area will respond to the damage to a single plant because of various chemical cues that are being spewed out into the air. And we know that animals listen and pay attention, and plants are paying attention not just to members of their own species. They're paying attention to everything. So now what I want to know is, when the rays or bony fish get all stressed out and release their chemical stress hormones into the water, does everybody listen and go, oh, shark, oh, I gotta go? And so does it not really matter? And do the rays listen to the bony fish stress signals? Like, I'd be willing
to make a sizable monetary bet
on this. This one, yes.
That's a yes. I mean, think about it. Like, there's a reason that terrestrial animals, that they listen to other animals' calls, because there is a selective pressure to not get eaten.
Yes.
And so if you listen to like, if you notice when a meerkat says, hey, there's a predator coming, and you're a completely different animal, and you're like, well, I'm gonna scoot, and you survive as a result of that, then there is a selection for paying attention to other animals' cues. So the sea has oceans have way more evolutionary history than terrestrial animals. Of course they're listening to each other. Of course. They have to be. How else can you survive millions of years of evolution under the water of just fish eats fish eats fish eats fish? You have to listen to each other.
Yeah. Especially in the murky waters. You got to figure it out. Yeah. But we don't think of, and I think this is part of the thing of the human perspective, where of course we're paying attention and we're listening to all the animals and all the people and whatever. But there's this idea of, does it take intelligence to pick up on these cues and respond to them? Or which ones do you respond to? Do you know that certain fish are, crying wolf more often than others? Do you figure that stuff out? I think these are the cool questions to come up.
Yeah. Yeah. And I will just really quickly throw an answer out for Fada in the chat. He's asking, would you please give examples of other animals like the mice that naturally inherit behaviors at birth? So what this gets down to is what Kiki has been saying this whole time, which is how, which we don't have a lot of good answers to. Okay, so we know in humans there's behavioral responses that can be inherited, mostly due to stress hormones. That is the how that we know about in humans. However, the other things that we see in animals, the kind of the famous example you could give is the crows who avoid a particular person, a particular face, and then their babies end up doing that as well. And the assumption has always been that there's some sort of information exchange, but we don't know that because, again, we don't have the how. We don't know how that crow is passing on that behavioral change. We also know that for animals that show preference, a lot of the time there are preferences that are passed down. Could it be the colors of decorations that they put in their bowers, or a food preference, or a preference for a type of nesting materials? There's a lot of research on birds with this, actually. Yeah. But again, we know that these things get passed down, but we do not know how, if it's nature or nurture, or as things usually are, a combination of both. Right. So I think this is a really rich area for people to potentially study more. Of course, there's epigenetics as an option. Of course, there are behavioral stressors that can change the way that proteins are created. There are a lot of things. There's a lot of different like opportunities. Hormones are usually like the easiest solution if you're looking for something that is not a behavioral or teaching experience with the mother or the parent to the child. It's usually hormones. But in reality, we just don't know. There's lots of examples of this out in the wild, but we really do not know. Like, you know, patterns of webs, those can be passed down from spider to their babies. How do they learn that? We don't know. So there's lots of opportunities.
So many questions about these. What are the rules that the neurons learn, and how do the genes control those rules? How does the DNA create the proteins?
Yep. Dolphins and their use of the sponges, right? They pass that down from generation to generation. Whale calls are generational, and can be passed through family lines. So yeah, it's infinite. Actually, sorry, I'll stop now.
I don't know, but some, you know, there's also interesting things related to, you know, the differences. They've shown that, what is it? tRNA, not tRNA, microRNA that is transferred in the semen of human males can change the genetic output for an offspring based on how old the father is. So a younger father has different, and so this is kind of the epigenetic stuff, but not. And
then there's also like the whole
real
thing
world,
where like
live impact transfer of your life. Yeah,
and the thing where if you have an egg from one person and a sperm from another person, and that baby is gestated in a surrogate, some of the surrogate's DNA ends up in the baby.
Yep.
And we're still not 100% sure about how that works.
Nope.
So, yeah.
How'd that happen? Don't know. It just does. Okay.
That baby has 3 parents. I don't know.
I have a story that I thought you would like that I just wanted to throw in here. About a spider that was just discovered.
Yes.
It's a brand new spider that, thanks to citizen science, they were able to identify it as a new to science spider. And a lot of like New York Times and Gizmodo and others are calling it the Last of Us zombie spider, because this spider, it grows it mimics other spiders that have fungal growth on them. So there's like a cordyceps related, so the fungal species from Last of Us, the TV show that was controlling everybody and like made zombies. This isn't cordyceps, but there are other spiders in the Amazon where they get a fungus that's related within the family of the cordyceps, and this spider doesn't actually have that fungus, but sits in little places and sits there and doesn't move and has these little growths on it so that it looks like
that's amazing.
A cordyceps spider.
Yes.
And so basically it looks like it has been taken over by fungus, but it has not.
I love that. Yeah.
And so it is a spider that it's using mimicry, and it doesn't make webs. It doesn't do a whole lot of things that spiders that we typically talk about do. But this is the first example of a spider not just mimicking a fungus, but mimicking other spiders that are covered in fungus. The idea the researchers have is that this is smart for this spider because if predators, number one, if it's not moving, it's not going to be noticed. Number two, if it looks like an insect that has been taken over by a fungus that's dangerous, that they've learned not to, again, how did they learn not to eat these? But if predators don't want to eat zombified spiders, they're not going to eat this spider. And so the mimicry has come about in some way, and So it grows something of an egg sac. It's got this it's a really interesting species, and yeah, not a
It's so fun. So is that all like that's all parts of it? It's exoskeleton.
it's exoskeleton, yeah.
That's
So
so cool. So this
yeah.
would be we just talked about this on my other podcast.
Ah,
This is what would be considered Batesian mimicry because
mhm,
they are mimicking something that is toxic or dangerous. And so if a predator would not want to eat
mhm,
an infected spider or a spider with toxic fungus on it, then
mhm.
them looking like they have toxic fungus is I just think it's very funny a spider having to do that because
Right,
it's like
and so
already a spider.
it's
It's
already
already
a
super
spider, but it's
dangerous.
small, and in
Yeah.
the Amazon, it's
Hmm.
probably pretty good prey for a bird or for frogs or whomever.
That's such a
Um,
strange ovisac. What?
yeah, so this an image that I have on screen right now is of this spider, which they have named Tox Zanowskia waska,
Hmm.
and with an ovisac. And so this ovisac is a dark bear, like a berry, looks roundish, like a
Hmm.
fruit of a berry, um, and has a very dark color, almost as if it's like dried blood or something. Um, and it's connected to the spider,
Interesting.
which is very interesting, very odd.
She's taking her babies to go.
Yeah, the researcher who has I described this spider, named the spider with the help of iNaturalist citizen scientists who helped her realize that it wasn't just a fungus and was actually a spider that
That's
she was
so
looking at when
cool.
she was first doing the studies. Um, she went looking and found the first example of a specimen of this species in a collection from 1903. So they've collected these spiders, but hadn't identified
Hmm.
them until now as a brand new species.
Wow. That's
Yeah,
awesome.
brand new species in the Amazon.
I love that.
Pretends it's a spider infected with a fungus.
Yeah.
I think it's awesome.
Oh,
Isn't that fun?
that's great. I love it.
Yeah, on so many levels. Okay, 3 more studies
Yeah.
real quick. This one I think is great because um, everybody gets older and has knee pain pretty much.
Uh huh.
And I personally know several people who have gone in for knee surgery of different types. At least one person who's gone in for knee replacement surgery. We know these people all over the place. Our knees are one of the weak points in our human skeleton, in our human structure. Researchers from the Radiological Society, or published in the Radiological Society of North America, this last week, their work of an almost 200 patient prospective single center study related to osteoarthritis and knee pain. And so they had 114 women, 80 men, and all of them had failed to get any relief, adequate relief using regular treatment, anything previously. They had not had surgery yet. And then we're looking at people who are about median age of 69 years old, median body mass of 28.4. They found a lot of these individuals coming in weren't moving around. Their pain in their knees had led them to being less active. So there was a lot of like their lives were being impacted by this stuff. The researchers have a brand new treatment. They call it genicular artery embolization, GAE. Genicular artery embolization. It's a non-surgical procedure. They inject a compound and they use a catheter to reach particular blood vessels that develop around osteoarthritic knee joints. These blood vessels, I didn't realize this, but apparently lots and lots of blood vessels grow in the arthritic knee joint. And the more blood vessels grow, the more they cause inflammation. So the blood vessels are there and they're like, ah, la, 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 and they put out all sorts of inflammatory proteins and they're signaling. And so the immune system is there and it's a cascade that keeps going. And so there's more vascularization and more inflammation and more pain. And it's a cascade that keeps going. And so in this process, they have a new methodology of using these resorbable gelatin-based microspheres, and they have these particles that they put into the knee right near the veins, near the blood vessels, and they deliver a cocktail that kills the blood vessels. And so it gets rid of a lot of the blood vessels in that area. They looked at the knee joints of these people and talked to them about their pain and their experiences over a period of 12 months. 80% of people had massive improvement, way over baseline in their knees. This is a really, it's a small sample, but basically they saw that the individuals were reporting less pain and they were going out and moving again. At their 12-month follow-up, 80% of the participants exceeded the threshold. And they say, our study demonstrates that GAE using rapidly resorbable gelatin-based microspheres is a safe, minimally invasive therapy that provides meaningful pain relief and functional improvement in participants with osteoarthritis-related knee symptoms for at least 12 months.
Nice.
Yeah. And the study is kind of cool. The images that they show, there's like an obvious decrease in the vessels, the blood vessels that are there in the veins in the knee. So there's an area of blood vessels after the embolization. There's really not. And overall, it was lots of improvement for everybody.
Yeah, even if it's not a universal solution, if you can try this before you get to surgery. If
it can keep you from getting to surgery as quickly.
Yeah.
Right.
Or so if you as a person just don't ever have to have surgery, like Susie over there might need it, but just having less people have to go through general anesthesia and go through surgery, like monetarily, but also for the recovery time, losing work, losing mobility, having to do rehab afterwards to get your mobility back. Like there's so many possible upsides to avoiding going through an actual surgery. That's great.
Yeah. I think it's amazing.
Nice.
My advisor from graduate school, Vladimir Pravasudov, has published a study this week. We're going back to animals right now for a second. Away from painful knees and into choosy females.
Uh-huh.
It's breeding season. We've got all the babies fledging right now. If you wander around in the woods, you're going to hear lots of as the babies are begging for the food from their parents. But, some of those parents in monogamous species with parental care by both the male and the female, in some of those species, the males, or in some of those couples, the males are taking care and feeding little fledglings that are not their own.
Oh,
that very
stepdad.
Often there's cuckolded dad.
Oh no, even spicier than that. Okay, got it.
It's spicy. We're talking about cuckolding and chickadees. So the chickadee, the wonderful, wonderful North American chickadee, is monogamous and they're non-migratory. These birds are incredible. You see them in the North America, black-capped chickadees and mountain chickadees. You'll see in the mountains. We've got a bunch of black-capped chickadees and chestnut-backed chickadees here in the Portland, Oregon area. But these black-capped and mountain chickadees, you will find them going up to Alaska, and they have been shown to have incredible spatial cognitive abilities. They don't migrate. These species that go higher up in altitude where winters are harder and the food supply is less also go further north into the Alaskan regions where the winters are much longer and colder and harsher. They rely on their memory for food stores to be able to survive during those harsh periods of time. The smarter you are, the bigger your hippocampus can grow, the better you can remember locations and find food, the better you're going to survive. And if your brain is big and you can find spatial locations really well, maybe your offsprings will be too. And so the researchers, Vladimir Pravasudov and his colleagues, published in eLife, so it's an open access article you can read if you're interested, their work on mate choice versus extra pair copulations or cuckolding. And they discovered that these female birds are more likely to take an extra pair copulation with a male and have his offspring if a male happens to be better at spatial cognition than their partner. So they
She
find
just wants the best for her babies.
So a female says, "Oh, you're really good. You're better than my partner. Okay, we'll do that. We'll do that." And so, yeah. Also, though, they found that if it's not the more spatially aware females who have these extra pair copulations, it's the less spatially aware. So
they're making up for it.
The females who can't find their keys are making up for their own their own spatial issues.
That's so funny.
And that is actually the primary driving factor even before the spatial cognitive abilities of their partner. And so they used genetic monitoring, they did memory studies, they used a whole bunch of factors to be able to figure all this stuff out. But basically the better a male is at spatial cognition, the more that female chickadee is like, that's great.
Man, that ovum, it's valuable.
You know where you can remember the food? I want to have your babies.
Don't waste the ovum, you know?
Don't waste the ovum. Yeah, especially in harsh environments, especially environments where food can be limited, where dates can be limited, where, I mean, it's a survive at all costs situation, and we can make jokes about it, but it is, the survival that has led to these adaptations and these ways of choosing. That the female species being more choosy, I find it fascinating. So interesting.
Yeah.
Yeah. So how did we choose our husbands? No.
I mean, he is very good at finding food. So
Marshall can find snacks. He's good at finding snacks. He's also good at finding like the food delivery app. No.
I mean, that works.
That works.
He's providing.
I know. I love you, Marshall. Final story for the night, and it's just a really quick blurb because I know for a fact that everybody in the chat is going to say, well, duh. News out of Flinders University. Researchers in marketing at Flinders University's College of Business, Creative Arts, Law, and Social Sciences has found that gamers, people who play video games, their brand loyalty can lead them to be very critical of the game itself. That they discovered that those people who are the biggest fans are actually most likely to be the harshest critics of those brands, at the same time as being the most staunch supporters. So anybody who comes in from the outside criticizing is immediately going to be attacked.
I see.
But on the inside, you know what's going on, and so you can criticize all you want. And
this is a connoisseur situation.
It is.
Like, if you are a sommelier, you're going to be very critical of a vintage that does not hold up. But you are also going to be able to say, this is a good vineyard. Right?
Exactly.
Like,
yeah.
It's just, I think it's probably just the lens, right? Because it's like, oh, it's video games. Like, it's not seen the same way, but just like somebody who is a musician and who knows music might have a favorite band and also might be highly critical of a band's latest album. Like, you could assign this to like anything, right?
Yes.
Just because gaming is kind of delegitimized, I'm sure that the
also
frame
it's
is
very,
kind
very
of different.
commercial. It's also very commercial. Yeah. And in the marketing aspect where this study was looking at it, they're looking at it from the marketers are trying to push different marketing angles and different conversations in chat rooms, on servers, in social media, but by shutting down the voices of the critics, what they can be ostensibly doing is shutting down their biggest supporters. And so the researchers are saying you might want to check on what who is making the criticism, why they're making that criticism before you go about deleting comments and quieting people down and fighting back. Because if you want your brand to succeed, that brand loyalty comes with the investment in the entire product line, right? In all of it.
Yeah. Well, that's also why like beta testers are so important in the gaming industry, right? Because like those are the people who are going to cut through the game, explore every inch of the map, really like pour their heart into the time that they spend in your game that you built, to then be able to provide the valuable feedback to make sure it's ready for launch. So like, I think that, you know, that this reminds me of Sonic the Hedgehog, speaking of games, but just like what happened, right? That the movie, they released the trailer for the movie, people flipped out. And instead of them just being like, oh, you guys are just haters, they actually went, ooh, maybe we should adjust.
They decided that it didn't look good. Everybody was like, that looks wrong.
Yeah. And instead of them just being like, you just don't like a 3D Sonic, they were like, okay, we hear you. They adjusted it. And now they've made like 4 or 5 movies, and Sonic is coming back to games and all this kind of stuff that probably would have never happened
if they hadn't listened.
Yes. And so I think that's I would like more corporations to take note of the Sonic the Hedgehog effect, because I feel like listen to your biggest customers. Like, remember that we are customers, not consumers, not to bring it back to this again, but like, we're customers, not consumers. Yeah. Like, give us what we want, ask us what we like, adjust, like take your biggest fans' advice.
And I'm looking
really important.
Yeah, and I'm seeing people bring up Star Wars in the chat. Sure. And that is not I mean, we're not going to the video game world of Star Wars here. Right. I mean, that's part of the entire universe. But in terms of the movies that have come out, what has happened is it has the entire corporate movement is driven to selling to kids.
Right.
And they realized they could sell toys once upon a time after the first Star Wars. And so everything has included kid-friendly ever since. And there are cartoons and really poorly animated 3D shows that I can't even watch because they're so bad. And people are like, you should watch it. It's really part of the lore and blah, blah, blah. I can't watch it because it's awful. Because what they've done is they don't respond to their core fans. They are only interested in perpetuating an audience of young fans who could potentially grow up into being older fans. And so the older fans really are always angry and stuck with nostalgia.
Yes, but see, the Star Wars is strange for a couple reasons. So without getting way too far down this rabbit hole, one, I just rewatched for the millionth time the original trilogy, and they are children's movies. So
Yeah.
that's part of it, is that they've always been children's movies. They will always be children's movies. Like, part of it is that we have grown up and we are adults now watching
Speak for
children's
yourself,
movies.
Claire.
So
No.
like, this is, you know, that's part of it. Okay. And I
Yeah.
recognize that it's taken some strange turns, and I'm not here to apologize for it or defend it. But just as context, I think it is important to remember it has always been for children. Okay. But that being said, the other thing I think is really funny is that the prequel trilogy, when they came out, everybody hated them. And now there's an entire generation of people
That was
who
those are their
love
movies.
them, because those were the movies that came out when they were kids, which means in 15 years, there's going to be a group of people who loved the sequels. And part of it is that they have been and always will be kids' movies. And if you were a kid when your Star Wars came out, you have a soft spot for it. Like the people who love those 3D animated TV shows, it's because they came out when they were young. Some of them. Some people love them, and that's fine. You're allowed to love them. But a lot of the mass appeal of those shows is because they were on like Cartoon Network or whatever it was when people were in like middle school and high school. So like, I think that that's part of it, is like, there is nostalgia involved. That being said, I know that there's an entire huge fan base of Star Wars adults, myself included, that would love to tell Disney what I would like to see. For example, a What If series, but with Star Wars.
Yes.
So
Yes. But
there's
I mean,
stuff
series,
out there, right?
Andor.
Yes.
Andor is one of the best TV
Not for children,
series.
I will say.
Not for children. Not
for
for children.
children.
But I will say I will watch any show that is like that. So Disney, if you want more Star Wars for adults, we need more Andors. I need more of that, like real, like wonderful writing, great acting. Like it was so good. I know, but
I
this
agree.
is not I was making the comparison because what they've decided to do in a corporate way is only focus on new audience generation, and they just throw bones to the fan base.
Yeah.
Right?
Well, and partly that's because they want biggering and biggering and biggering, but they don't recognize that by adding to the top, sometimes they are losing the bottom. Like they are losing their diehards by trying to add. Yeah, absolutely. And if they listened to the connoisseurs, they might actually be creating better content that it has more mass appeal.
More better content. Yeah. Absolutely. Yeah. So anyway, don't shut down your critics.
Yeah.
I mean, you got to listen to people, and I try to do that here. And so, yeah, Rebels is dope. That's true.
But I think that also, like, another thing to remember is that the reason people get so passionate about this stuff, or they're so hard on it because they're passionate, just like the sommelier or the musician or, you know, the Star Wars nerd. It's because they're so passionate about it that they are so critical. And I think that, like, this is a conversation I have with people all the time about Star Wars, actually, that, like, I'll get riled up in a conversation about it. And they're like, but I thought you loved Star Wars. I love Star Wars. That's why I'm so excited about it. Because it's, if you really dive deeply into something and you're passionate about it and you, like, expand your knowledge on it, you form opinions.
And you have evidence to back those opinions. You have ideas. And
absolutely.
Long live the fans. Long live the
absolutely. Yes.
people who love things.
How about our fans?
Enough to care.
You guys still there?
They are. Yeah. Our in-law called us nerds.
Yeah.
Nerds. Absolutely.
100%. Never not been.
Paul Disney. So the lesson, eventually people grow up and become wrong. That is not the lesson. Wrong lesson, Paul. And no, you never forget your first Doctor Who or your first James Bond or exactly. This is a good one. Long live and prosper. Live long and prosper. Absolutely.
Long live. I like
long live
and prosper.
I know. I can't talk anymore.
Long live and prosper? Is it like this?
Long I don't know. Have we done it, Blair?
Mm-hmm. Yeah.
Awesome. Wonderful. We have done it. We've come to the end of another show. Thank you, everyone, for joining us. We're so glad that you've been here for another night of This Week in Science and another week. And we hope that all of you will be back again next week. But in the meantime, thank you to everyone in the chat room for hanging out and chatting and being here to talk and to enjoy the show and the science that we were able to bring to you tonight. Shout out Fada, as always. Thank you so much for your work on show notes and the social media side of things. You help so much. Identity 4, thank you for recording the show. Gord, Aaron, Laura, others who keep the chat room safe places to be. Thank you for helping out there. And and also, Rachel, thank you for editing the show. And without further ado, thank you to all of our Patreon sponsors. Thank you, Aaron Anathema, Adam Mishkan, Alan Viola, Ali Swanson, Andrew Swanson, Artem, Arthur Kepler, Bob Calder, Bob Cowles, Brendan Minish, Brian Carrington, Chris Wozniak, Christopher Dreyer, Christopher Rappin, Craig Landon, Craig Potts, Daryl Myshak, Dave Wilkinson, David E. Youngblood, Don Mundus, Eden Mundell, Eric Knapp, Flying Out, Fredis 104, G. Burton, Lattimore, Greg Briggs, Jack, John Old, Jason Olds, John Atwood, John McKee, John Ratnaswamy, Johnny Gridley, Ken Hayes, Ken Northcote, Kevin Parachan, Kevin Reardon, Kurt Larson, Lon Makes, Lauren Gifford, Mary Gertz, Marjorie, Mark Hassenflow, Mark Jenkins, Noodles, Patrick Pecoraro, Paul D. Disney, Paul Ronovich, Philip Shane, Pierre Velazar, Richard Badge, Robert Norland, Robert W. Farley, Rodney Lewis, Rudy Garcia, Remy Day, Sean Clarence Lamb, Chubru, Stephanie Embry, Stephen Alberon, Steve Leisman, aka Zima, Sue Doster, Teresa Smith, Tony Steele, and Vigard Schefstad. Yay! Thank you, all of you, for your support on Patreon. And if you would like to support us on Patreon, head over to twist.org and click on that Patreon link. $10 and more, and I will try to pronounce your name at the end of the show. On next week's show,
we'll be back on Wednesday at 8 p.m. Pacific Time, broadcasting live from our Twitch, YouTube, and Facebook channels.
Oh, yeah. Want to listen to us as a podcast? Just search for This Week in Science wherever podcasts are found. And if you enjoy the show, please get your friends to subscribe as well.
For more information on anything you've heard here today, show notes and links to stories will be available on our website. That's at www.twis.org. You can also sign up for our newsletter.
And we love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, please let us know on one of our social media accounts or send us an email. Just put TWIS in the subject line so your email doesn't get spam filtered into where, Blair?
Oh, the deep, dark recesses of a comments page.
Bye. It's gone.
Mm-hmm. Mm-hmm. Oh, no, wait. No, I already said that. We look forward to discussing science with you again next week. And if you learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan.
Let's see after show. How's it going, Blair?
good.
Good. Is there a child awake in the other room?
Unclear. I should probably go check.
I'm watching you lift the Headphones off, going.
Well, of course, I got in there and
Mhm.
and he wrapped both arms around my head and like snuggled up, and I was like, "Oh, I'm not going anywhere for a couple minutes."
Oh, no. Yeah.
But he threw a leg around too onto me, so I was just like, "Oh, okay, yeah, mm-hmm.
You're not going anywhere. You're mine.
Yeah.
Oh, whoa. Okay, what do we have here? Noodles. Cheers. Hello, Noodles. Have a great night, Lon. Thank you for being here.
Oh, Arnlore, you can just email me. You know what my email address is. You can email me
Twitch
at
did
the
ask.
TWIS email. That's fine. Or yeah, Instagram's the only other way. I don't have like a message board or anything like that. Yeah. Email me. We're still just a baby podcast.
It's nothing special.
Episode 7's coming out tomorrow. It's not, And yes, we're going to get things wrong.
Yeah.
Made that very clear. But I think I might actually do like a full corrections episode in between season 1 and 2, because obviously
fun.
But
you could take it a whole bunch of
everything, and
but you could get a bunch of letters.
Yeah.
Yeah. That's awesome. Are people mostly emailing you or?
No, mostly Instagram so far.
Okay.
But it hasn't been too much. We self-corrected a little bit. No, we like looked in between episodes and followed up on things, and then had a little correction section on a couple of our episodes. But I know I missed a couple pretty egregious things, which is normal. It's a podcast. You're like talking in real time.
Yeah.
And so, yeah.
Egregious, though. I mean, that's quite a word.
Well, it's just like, I said, like, I don't know about any animal that does this. And then somebody commented on Instagram and went, this animal does that, duh. I'm like, oh, snap. Got it.
Oh, okay. Thank you. But now I know. Thank you.
Yeah. Oh, yes, Arnlore, you found 2 while binging. Well, I'm happy to hear you're binging. I hope you're enjoying it. Yeah. And hopefully the mistakes are not making it less fun.
Maybe the fun is going, haha, you made a mistake.
It's one of those podcasts where you're just supposed to be like overhearing a weird conversation at a party, right? So it's like we're not trying to be that serious. So it's everything's fine. There's no stakes.
It's for fun. Yeah. Do an updates episode so you don't have to admit mistakes.
Right. For sure.
That's funny, One by Land.
Yeah.
Oh.
Mm-hmm.
Who was it earlier? So that was here a long time ago. Derek. I think Derek was up. Derek had to go while listening. I think Derek was hoping to hear a Derek name on the show tonight. But no, I said it now. Derek, thank you for being here. Everywhere. Derek. Only one of the 2 was you, Blair.
Okay. Well, it's still kind of my show, though, so I have ownership.
Yes.
Okay. Yeah, I do have to go, I think.
Fantastic field guide.
Fantastical
field guide. Yeah, I'm just getting this right now while we're here and going like that.
Ooh,
look at that. If you put it out there, maybe people who haven't seen it will see it and know how to find it.
There you go.
Thank you. You're welcome.
I'm going to be on DTNS next month to promote it.
Awesome. So
that's nice.
Did you reach out to them or did they reach out to you?
Well, this was all part of Experiment Week. So I think this is them trying to like...
And they're coming back with doing their Experiment Week again.
That's great. I know it only took me 2 years to get this off the ground from the initial pilot. I think I might try to air the pilot during the break too. We'll see. Just because we have to take like 4 or 6 weeks off just because...
life, and you have to do
we have
new
to release
episodes.
seasons,
And
and
Yeah.
we can't record that often because we all have
I know.
jobs and children.
And you have another podcast.
Yeah, that I do every week.
I know.
So
Thank you.
when I can.
Thank you.
Okay.
We enjoy it.
Well, thank you for sharing that.
Yeah.
Yeah, I'm gonna go check because either Brian might be stuck in there actually, so I should go check.
But if he's stuck in there, is that a bad thing?
No,
Like,
it just
no.
means that he's asleep on a child's bed. And should probably be rescued before his head falls off.
These are the things that happen, though, while you're
Yeah.
parenting. It's
Yeah. Also,
The
if
life
he's
of-
still in there, that means no one's done dishes yet, so I have to go do
Oh.
that before I can go to sleep.
Which means you have to do them before you go to bed.
Yes.
Oh, see, I'm on the other side of this, where once upon a time it was just me and Marshall making messes, cleaning them up. Now I have the child, and the child was small, so he would make the messes, and I would clean them up.
Yes.
And now Kai is older, and I try and get him to help with the cleaning up.
Yes.
But what happens is his responsibility is cleaning out the dishwasher,
Oh God.
and if he doesn't clean out the dishwasher, then I have no place to put dishes. And I don't want to clean out the dishwasher
Right.
for him
Yeah.
because that is not the lesson.
Well, sounds like he can't have that job anymore. He has to fill the dishwasher now.
God.
Sounds
Is
like
that
he cannot be trusted with the easier job.
I think he needs to do both
Yeah.
and have to do it at a particular time every day
Yeah.
so that it doesn't just kind of go, when
Yeah.
I want to, Mom.
See, Noodles, you can't wake up to the mess in the morning, and let me tell you why. First of all, I have to wake up at 5 o'clock so I can go to work. Second
And
of
you gotta make
all,
the coffee in the morning.
second of all, I have to make the food for the child
Yeah,
and
you
serve
need
it on dishes that are clean before I leave. So
Yeah.
these are all reasons that I unfortunately have to do it before I go to bed. But
Yeah, you just got to clean it up.
yeah.
¿Por qué no los dos?
Yeah.
Sí. Ah. Right, Arnlor. And before getting to do fun things.
Mhm.
One of these days, I'm just going to take his phone out of his hand and say, you get it back after you do dishes. It's just one thing. That's all.
I know. Get him to do one thing.
Please
definitely-
help in the household. Small, not so small child.
Taller than me now, child, right?
He's so much taller than me.
My child is quite long. I have a feeling he's going to be taller than me too.
That's fun.
Yeah.
It's all so fun. Who are they going to be? What's going to happen? It's so amazing.
I
so
know. It's
interesting.
funny to see
Yeah.
which things like continue, like preferences and things, and you're like, oh, this might actually stick around. Like he might keep this.
Mm-hmm.
Versus things that are kind of fleeting when they're
Yeah.
babies and toddlers, where you're like, oh, you like this today, maybe you like that tomorrow.
Mm-hmm.
But then you're like, oh man, it's been like a year. You still like this one thing.
Yeah.
This is probably going to stay. And this is probably something you're going to remember also.
Mm-hmm. Yeah.
It's wild.
Kai does not like sweet potatoes.
Mm.
He would figure it out. Like anything I put sweet potatoes in, like when he was a baby, he would spit it out. And he still detests sweet potatoes. It's
My child
fascinating.
hates banana,
Why?
which
Kai
is
hates
very
banana.
unusual
Kai doesn't like banana either.
for a child. Yeah.
Yeah.
They usually love them.
No, he's like, he still doesn't like banana.
Hmm. Which I hate banana. So is that something I passed on?
Maybe.
In the womb? Who knows?
That's right. Could be. I don't know if it's allergies.
It's not allergies.
I don't think it's allergies. I don't
All
like
of it.
banana texture.
It's mostly the smell,
And-
actually, that I can't stand. And the fact that
Oh,
it
I
makes
hate
everything else
fake
around
bana-
it smell like banana.
Fake banana
Oh, yeah. Disgusting.
candy flavor. And
Yeah.
that is the worst.
Mhm.
It's like really the worst. I will, yeah. Oh, that and fake cream corn flavor.
Ooh. I don't even know what that is. Blech. I've probably had cream corn once in my entire life, and I was probably in Atlanta. That was, I think I did. It was when I got the vegetable plate. And it was creamed corn, macaroni and cheese, vegetable lasagna and white sauce.
Oh my God, it's all beige.
That was the vegetable plate that I got.
I wouldn't have been able to eat any of it.
I was like, take me back to California, please. Immediately.
I would have been like, do you have any Lactaid?
Do you have a single leaf of lettuce? Can I have a leaf, please?
No, because it's covered in a pound of shredded cheddar cheese.
Yeah.
Oh no, Kiki grew up and just wrong. Sorry, Paul. That's right. You made your banana wine. I remember that.
Wow. No.
You did. You made the banana wine.
That's illegal. You should go to jail for that.
I'm not allowed.
Banana wine.
Maybe you were out, Blair. Maybe you weren't there when I was talking with Paul about his banana wine. Yeah.
It's a good thing that my stomach is good today, because that would make me want to eject my dinner.
I'm sure it's delicious.
Wine. Oh my God.
If not nutritious. Oh, almost have another batch ready.
Oh, that's so nice. Put it in the garbage.
Blair!
Listen, that's fine. You enjoy. You enjoy.
Epicurious George.
Keep it very far away from me, if you would. Thank you.
I love that. I bet the label is fantastic. No, I need it. Yeah. That's awesome.
All right. Well, on that note, banana wine. I gotta go.
Say goodnight, Blair.
Good night, Blair. Say goodnight, Kiki.
Good night, Kiki. Good night, everyone. Thank you for joining us for another night. And I do hope that you have a wonderful week. Find ways to have simple joys. Enjoy those days. If you can't enjoy the full day, at least find a moment. And stay smart, stay healthy, stay curious, and of course, stay lucky. Bye.